And welcome to week 5, day 4. We're going to talk more about AutoGen Core. You remember AutoGen Core, the fundamental, the bottom layer of the stack for AutoGen, and it's an interaction framework. It's responsible for worrying about how agents play together. It doesn't care about how the agents are implemented, although it works well with agent chat. It's somewhat analogous to LangGraph, but except rather than focusing on repeatable workflows, it's focused on the interactions between diverse agents. And in particular, we talked about 2 different types of runtime, the standalone, the distributed. Last time we talked about standalone. Today, we're looking at distributed runtimes. It's going to be even higher level than last time. And it's just to give you that flavor. And I should also point out that Microsoft says that the distributed runtime is still experimental and the APIs are liable to change at any point. So it should be taken in that light. It's not actually ready for a production system yet, but it's more of an architecture, an idea, and an exciting idea in terms of future possibilities. And the distributed runtime itself that we're going to look at right now is described as something which handles the messaging across process boundaries. That's the idea. It's no longer a single-threaded thing running on our machine. It's something that can run across different processes that might not be Python processes. They could be anything. And it consists of 2 different things, 2 different components to it. One of them is called the host service, and that is the sort of container that runs this. And it connects to a worker runtime or potentially many worker runtimes. And it handles the delivery and it handles sessions for direct messages that are going to be handled by gRPC. If you're familiar with that technology, remote procedure calls, and it's going to handle the session management around that. All of the nuts and bolts of the infrastructure around the complicated business of sending a message remotely from one computer to another, from one process to another, that'll be taken care of by the framework. And then the other concept here is a worker runtime. That is the runtime that will be able to treat much as we treated the runtime in the single-threaded case. And it will be able to manage different agents. It will have different agents that are registered with it. It will advertise the agents it's got to its host service. So the host service knows what it's got. And it will actually handle, of course, executing the code. The worker runtime has the agents, which themselves are delegates for something that does something. And that will be handled by the worker runtime. So that's how it fits together, but it's going to be more concrete when I show it to you, which I'll do right now. And so here we are back in Cursor and in the number 5 folder for AutoGen and going to lab 4. AutoGen Core Distributed. I'm only giving a teaser of what this is about because to be honest, I'm not even sure how relevant this is to many of you. So I'm going to give a flavor for it. If you do want me to go into more detail, if you want more content, then please do send me a note. Let me know. I can always go deeper into this, but I don't want to hold others up. I think that particularly as Microsoft is saying that it's still experimental, it's better to get a flavor for it. Okay, so I've done this, and there's actually 2 different ways that I want to show you this working. One of them is what I'm calling all-in-one worker, and one of them is with multiple workers. And so I've got this flag here that you can set from true to false, and we're going to go through it once with it at true and then once with it at false, and you'll see what I mean. So we do some imports and we load the .env, and we start with our message class as before. I'm going to clear all that and restart, do this again. Sorry. Run this. I start as before with our message class, defining this thing. It's the sort of analogy to the state with LangGraph, although it's to describe how we interact between our agents. Okay. And now I mentioned that the distributed runtime consists of these 2 things. One of them is the host, and this is how you create the host. AutoGen X runtimes gRPC, the gRPC worker agent runtime host. So this is something which uses gRPC, the remote procedure call technique, to be able to send messages. And this host will run on my local host on port 50051, and I will start it with this. So this is now going to be a running host. And gRPC, of course, is a cross-language approach for sending function calls between different languages. And it's super powerful. It's used in many different places. You can think of it. It's like making REST HTTP calls, except you're able to call directly from one function to another. And gRPC is used all over the place where interactive messaging needs to be implemented that crosses process boundaries. So that is gRPC. We've started a host and it is running. And what we're now going to do is, first of all, reintroduce an old friend. We're going to bring back the AutoGen SERPer tool using our SERPer search API. And the reason the way we're doing it is through, we're doing it through LangChain. So we're introducing a few things from before. So we create the Google SERPer API wrapper. We create a LangChain tool for internet search. This is the same tool that we used last week. And now we wrap that in a LangChain tool wrapper so that it becomes an AutoGen tool. And there it is, an AutoGen tool for searching the internet using the SERPer API. So originally I was going to have this play rock, paper, scissors in a distributed way, but I realized that is a bit frivolous and we should be trying to at least have some commercial footing here. So I was going to make it do the stock price comparison. And I thought, we've already done some of them and we've got a whole week coming on that. So instead I've gone with this, we're trying to make a business decision. And let's say that business decision is whether we should use AutoGen in a new AI agent project. And we want to have two different agents. One agent research the pros of AutoGen by using web searches, and the other agent research the cons, the negatives, the drawbacks. And so the two agents will go off and do their analysis, do their searching, and then they will come together and we will have a judge agent that must make a decision whether to use AutoGen for a project. And it must be based purely on research from its team, from its agent team. Respond with the decision, brief rationale. So this is sort of by analogy with the rock, paper, scissors. We've got instruction 1 for player 1, instruction 2 for player 2, and the judge that will make the call. All right, and so now we have our agents, and this is, again, by analogy with last time, it's really very similar. Player 1, I've kept calling it player 1 because this really is a copy-paste job, basically. Except I'm using GPT-4o Mini for both because I thought it wasn't fair to use a Llama. We didn't get the same quality. So we've got GPT-4o Mini, so we are. This is the player 1 rooted agent, and we are passing in here. We're using the AutoGen SERPer tool. So that is what we're doing. I realize even looking at this that we don't actually need a player 1 and player 2 class. This could be done in a simpler way with just one. That's an obvious point. But anyways, for whatever reason, we've got two agents here, two different types of agent. But we're going to prompt it for whether it should find the pros or cons. But you could imagine you could switch in a different model here if you wanted. If you wanted to have DeepSeek do one of the research. So I'll keep it as two separate agents in case you choose to do that. Okay, so other than that, this is exactly the same. Other than supplying the search tool, reflecting on tool use, everything here is the same. It delegates to its underlying LLM, and the judge is the same. It also has a delegate, an underlying LLM, and in its message handler, the method that's decorated message handler, it collects the two messages that we set up above. It finds the two agents, player 1 and player 2. It uses this lookup, and then it calls send message. And this code is identical. Like, this is all exactly the same as the code we just used yesterday with the runtime that was local. And so the reason I do this, I want to show you that without changing anything, there's nothing here about it being distributed. It doesn't know that it's distributed. This could still be doing rock, paper, scissors. It would be the same thing. We're just calling self.sendMessage. And what we don't realize is that this is running remotely, and it's running on a runtime that's running on a port here. And it's going to be the AutoGen core is going to be calling the right function in the right agent. So these calls that appear to just be simply, I'm calling send message right here. I call send message, and that is going to result in this handle my message getting called. And before, that was just directly like some if statements in Python that were just making that call. Now this is going to be happening using gRPC remotely orchestrated by this distributed runtime. But that is completely unknown to us. As far as we're concerned, we're just doing exactly the same thing. And that is the power of AutoGen Core distributed, that we don't have to worry about the fact that these are different processes running, and they could be written in different computer programming languages. And all of the stitching together of messages is happening for us just based on looking up player 1 and player 2. Everything is happening. So enough prattle. Let's run that. Okay, and this is where the meat happens. So I've got two different implementations that I want to show you, and we're starting with all-in-one worker. And here's how it works. We first of all say that we want to create a new worker agent runtime, and we point it at our host. This is the host. So this will be a new runtime connecting to that host, and we will start that worker. We are then going to register 3 agents with that worker. Agent 1, player 1, player 2, and the judge. Here they are, player 1, player 2, and the judge, all being registered with this worker, with this gRPC worker agent runtime at that host. And there we go. There is player 1, player 2, and the judge. These are the factories that will create them. And we collect the agent ID of the judge. So I'm going to run this, and because this is set to true, only this code here is going to run. And it's done. And now this is the same as before. It's just the same thing. We're going to send the go message to the agent ID that I've just that I set here to the judge. And let's see what happens. So it's thinking, stuff is happening. Still thinking. Messages are flying. So what we hope is happening is that OpenAI GPT-4 Mini is coming up with pros and cons through 2 separate agent calls, and then a judge has put it all together. And this is what we get back. Pros of AutoGen, here's some advantages of using AutoGen in your AI agent projects. The cons are right here. Limited AI capabilities, less customizable, less structured, potential bugs, and performance issues with lower end models. Okay. But based on this, there's also some strength that appears. Memory, coherent context, ease of development, scalability, which is what we're experiencing, and versatile applications. And the decision is recommend using AutoGen. So based purely on this research, that is the decision. And with that, we will then stop our workers and we stop our host. And we have just experienced distributed AutoGen Core. And very briefly, as I promised, I want to show you what it looks like if we restart everything. And now we go through and we put all-in-one worker as false. What does this mean exactly? So we are going to, of course, have the same message, the same host that we start running on localhost at 50051. And we use the same tools, the same instructions. We make the same agents. Our agent code isn't touched, but now it's going to be managed differently. We're now going to run this, and we're going to be following this line right here. And this is actually going to create 3 different runtimes that I'm calling worker 1, worker 2, and just worker for the third one, the judge's one. And we're going to start each of these 3 gRPC worker runtimes. And then player 1, we're going to register with worker 1, player 2 with worker 2, and the judge with just the one that's just called worker. And so that is happening. And so what's the difference here? What we're saying is that instead of having our 3 agents running in a remote worker on our remote host, we now have 3 workers, and the 3 workers each running one of our agents. So they're now in different runtimes. They're all on the same host, but you could imagine that this is now, they're completely separate. This is something where things are interacting between runtimes. And so now we send the same Go message and presumably very similar messages. And now crossing the ether, one agent is calling GPT-4o Mini for the pros, one agent for the cons, and then as a result of that, they will come back to the judge, and the judge has come. We see pretty similar looking pros. The community and support is a new one, I think. Scalability is now put first. The cons, limited customization. That seems to slightly fly in the face of flexibility. I guess our agents disagree. Performance variability, cost considerations, and ethical and content control. Okay. But nonetheless, the recommendation is to proceed. That is the view of even when we distribute across multiple workers, it does still maintain that viewpoint. So there we go. That's the example I wanted to show you. I know we've gone through it quickly, but it's just to get that sense that the powerful thing about this is that without changing your code with the same definitions of your classes, these can be running in different configurations and different kinds of runtimes. And basically, what AutoGen is doing is it's handling message calling across process boundaries as transparently as if these were just simply classes with methods calling each other directly in Python code. That abstraction is what it's doing. And when you think about a future when potentially there could be millions or maybe even billions of agents interacting all over the place, what Microsoft is doing is putting their stake in the ground for this. This is a sort of playpen. This is a world where agents can live and interact. You just put your agent code within this wrapper, this agent wrapper. You make your versions of message that you declare the way that we have. And then your agents can interact with each other no matter where they are in the world and no matter what programming language they're written in. And with that brings us to the end of day 4. It means we're getting on to day 5. And in the spirit of the other things we've done this week, the project is going to be something that's more sort of an idea. It's more something to tease out some thinking, to give you some insights. It's not as much of a kind of commercial banger, perhaps, as the prior week, which is really great. But I think it will intrigue you in new ways. And a lot of what we've been doing with AutoGen is about stretching what you think might be possible. And that will be the plan for tomorrow. And I can't wait to show it to you.